Well, good morning, everyone. Thank you for being here. We're going to spend some time this morning to talk about lambdas and streams. I see that this room is really nicely packed. It's really very nice to see that. And I was pretty sure that knowing that most of us Java developers are men, autumn collections would have attracted many people. Maybe you might be disappointed because in fact, I don't have any kind of picture to show you showing nice ladies, nice top models wearing some clothes or not. So if you're here to see that, maybe it's still time to change room. No? Oh, okay. So this is about iterable and lambdas. As you may know, lambdas are coming. I tried to make it scary, but it didn't really work. Lambdas are coming, and it's going to be a revolution in the JDK 8. The first question we may ask is why were they introduced? It's a good question, and we'll try to answer this question this morning. Second question, why are they so important? What is at stake with this introduction? And the last question, how will they change the way we build applications? Because, as we'll see that this morning, the introduction of lambdas, and especially the new API, the stream API, will change many habits of ours, in the way we build applications. I am José Pomar. I'm an assistant professor at the University of Paris 13. I got a PhD in applied math and computer science. I also work as an open source developer on several projects and as an independent for companies. I have a blog called Java le Soir, which is mostly in French. It stands for Java at Night. But thanks to the magic of internet, you can visit it anytime in the day. And I also have a Twitter handle. If you have any questions, please use your Twitter account to ask them using this hashtag. We will take the questions during the talk, and I put 4 time slots in the talk so that you can, yes, okay, it works, so that we can gather questions and answer them. So let's introduce the lambdas first. And I would like to introduce them on a very simple example. But first of all, I'd like to know you a little. I know that this is the university part of Devoxx, so probably there are students in here. If you are students, can you raise your hands, please? How many students? Okay, not that much, but still. How many people have less than, let's say, 3 years of Java development? Okay. Less than 10. Oh my God. So you don't know how was the word before Java or before the collection API was introduced. Okay, too bad. So let's take a very simple example. Really the simplest example one can take, it's a person class. I'm sure everybody wrote that at some time of their life. And let's build a list on this person. This pattern, list equal new list, is a very important pattern because it's present really in every kind of application one can imagine. And what I would like to do first is compute the average of the ages of those persons. So how could I do that? Which is very simple. I take an integer, sum, and another integer that I call average. I will iterate over the list, gather all the ages of the person, and accumulate the ages in this sum. Then if I don't want to get this null pointer, this nasty null pointer exception, I'd better test if the list is empty or not before dividing the sum by the size of the list. Okay, this is very basic code. Maybe I can do something trickier, compute the average of the age of the person older than 20. It's pretty easy. I just need to add a test in my iteration. And I will also need to add a counter because, of course, list.size will not give me the number of persons older than 20. So I need to compute that number as long as while I'm iterating over the list. And at the end of the day, if, of course, n is not null, I can divide the sum by n to compute the average. This has a consequence is that the average of an empty list of person or of an empty filtered list of person is 0. Does it make sense? to tell that the average of an empty set is 0? Probably not. That might be an issue. This is what we call imperative programming. What is imperative programming? It's just this. It describes precisely what the CPU should do. Take a variable, put 0 in it, increment this variable, iterate over the list. It doesn't give a lot of room for improvement of this code. And this is the main problem of imperative programming. That is, if I look at this code, basically the CPU has to do that. The only optimization I can think of is in the way I iterate over the list. Here the list is just a list. Well, it's an array list, but I could change the implementation. Iterating over an array list is not the same as iterating over a linked list. And it's not the same as iterating over a skip list, for instance. There are several implementations, and the complexity as far as algorithm is concerned is not the same. But still, there's no much room for optimization. It doesn't have to be like that. I could have written this exact same code this way. Select average of age from person where age greater than 20. This is SQL language. SQL language is 40-year-old, so older than most of us in this room. And what the SQL does, it only describes the result. It doesn't tell the DB server how this should be computed. And I don't know how the DB server will compute that, and I don't want to know, because it is not my job to program DB servers. So there is much more room in that case for optimization than in the previous case. If I have a huge amount of persons, maybe some of the persons are in memory, some of the persons are on the disk, maybe the database lives on a cluster or something, but I don't care. All I want is the average, all I want is the result I just described. And this is what the DB server will do for me. Okay, let's go into a little more detail on this way of computing this average of the sum, because it's a very important pattern called map filter reduce, and I would like to go into detail on this pattern. So the first step is called the mapping. What does a mapping do? It takes a list of a given type, and it gives me another list of a different type. I give a list of person, and I get a list of integer, namely the ages. And the fact is that the return list has the same number of elements as the input list. This is very important. I change the type of the list, but I keep the same number of elements. The second step is called the filtering. The filtering is different from the mapping. It takes a list of a given type and returns a list of the same type. So this time the type doesn't change, but the number of elements does change. Most of the time it will be, I'll get less element because some of the elements will be filtered out. And the last step is the reduction. This is probably the tricky step. What does the reduction do? It's an aggregation of all the elements into a single one. Let's think about the sum, the min, the max, the average, something like that. We'll go into more details on the reduction. Okay, so this was just algorithm. Now I need a model for that to implement this in Java code. So how can I model that? Well, we still have JDK 7. We still live under the reign of JDK 7. So in JDK 7, I would create an interface probably to model the mapper. Then I can create an implementation of this interface. This is a special class to implement this. But I can also create an anonymous inner class to implement my mapper. This is, once again, very basic code. I can do the same for filtering. So this interface, predicate, it only takes one method, filter, that will take an object and gives me back a Boolean. I can implement it with a special class or implement it with an anonymous inner class. And the reduction is a bit trickier because it operates over all the elements at once. But in fact, I specify it over only 2 elements. So it will take 2 elements, think about 2 integers, and gives me back another integer, which in our case would be the sum of those two integers. So here's an implementation with a special class. and an implementation with an anonymous in a class. Okay, so this is nice. I've got three interfaces, mapper, predicates, and reducer. Three interfaces with three implementation, and if I apply the pattern, I will end up with that code. So I wrote it in a tiny font because I don't want to go into details in it. But what I would like to show you is that there's a lot of code, in fact, to write a very simple pattern, map, filter, reduce. A lot of boilerplate code in this program. And this is probably what I want to do, to simplify this code, to find another syntax for this code. This is really JDK 7, and this kind of pattern is 15 years old, and I probably don't want to use it anymore. Maybe I would like to want things to change. So what is the JDK 7? What does the JDK 8, what does Java 8 brings me in this room? Let's take our mapper once again with the anonymous in a class instance. And what I would like to do is to write it in a different way, removing all the, I can't really say useless code because it has a use, of course, but the boilerplate code. First, I can notice that I have only one method. As most of the methods in Java, this method takes parameter. Parameter has a type, and it has a written type, which is an integer. So let's take the parameter, %p, and then, so to write this and then stuff, I will write this little arrow to the right. Now there are arrows in the UTF-8 table, but I still write a minus and a greater than sign. And then return person.getAge. And I don't write the return because, well, it's obvious that I return person.getAge. And this is the basic syntax of Lambda expression. I take what is on the left part of the arrow are the parameters, and what is on the right part of the arrow is the statements and the return stuff. This is Lambda expression. This is the first syntax we can see. The compiler can recognize this as an implementation of the mapper, and we'll see. We won't see how, but we'll see what property does this Lambda expression has to have to be recognized as an implementation of mapper. What if I have more than one statement in the body of the method? Well, I can embrace the statement between curly braces. Like on this example, the curly braces are in red, just here, here, and here. And this time the return has to be explicit. I have to write a return. Okay. What if I have no return value? Well, it doesn't have any impact on the way I write my Lambda expression. It doesn't have a return value. Okay, so let's go. What if I have more than one argument? Well, I can put them between parentheses, integer I1, I2, then return I1 plus I2 between curly braces, or I can omit the curly braces and just write I1 plus I2. How can the compiler recognize this Lambda expression as an implementation of map? Well, this is a real question. First, there's only one method in mapper, so it's easier to tell which one of the method is implemented. If I had two, it might have been trickier. And in fact, there can't be two. There's only having only one method is a must. Second, the parameters and the return types are compatible with the signature of the method in the interface. And third, if there are any thrown exceptions, they also have to be compatible. So if all that works, then the compiler can recognize my Lambda expression as an implementation of this anonymous in a class. I can write more lambdas and it becomes quite natural. Maybe you're already familiar with this syntax, but once we are familiar with this syntax, writing more lambda becomes really very easy. Person brings me returns person.getAge. Int age returns age greater than 20. I1, I2 returns I1 plus I2. And guess what? I can also omit the parameter types most of the time. Maybe not all of the time, but most of the time. And this gives me an even lighter way of writing lambda expression because I can remove those parameter types. Think about it. This is the first time in Java that I can write something without writing a type before. When I write person hasn't been declared anywhere in my code. I don't give the type of the person, but the compiler is able to guess that type, to infer that type. Just a remark on the reduction, because I told you that the reduction was a bit tricky, and I would like to go into a little details about that. How does the reduction work? So here's an array of integer, very basic, and here is the lambda expression that will sum up two of the integers. The lambda expression is only defined on two integers, but I can apply it recursively on the array so that I will end up summing up all the integers of the array. How does it work? First, step one, I take the two first elements of this array, sum them up, I1 plus I2. The result of step one becomes an entry for step two, so I take this I1 plus I2, call it I1 in step two, take the third element of the array, and sum them up once again. And I do that again and again and again, and I will end up summing up all the array. Some people call that folding, because at each step, in fact, I reduce the amount of element I've got in the array by one, ending up with only one element. This is a very nice way of doing things. I just define a simple expression in two elements, and I can apply it on much more element, and I can go parallel with that. This is really great. Suppose I've got a C1 core, which will reduce half of the array, the right part of the array, for instance, and I've got another core, C2, which will reduce the left part of the array. And they will run concurrently on two different parts of the array, summing up their elements. And at the end of the day, I will gather the two partial results, sum them up. So once again, apply the lambda expression I have to get the sum of all the elements of the array. Now for that to work, I need a special property, which is this one, sorry. I need a special property, which is this one. And it's quite a trivial one on the sum, of course, which is I1 plus the sum of I2 and I3 equals the sum of I1 and I2 with I3. This is quite trivial for the sum, but if I write it with a reduction, it gives me that. If I reduce I1 with the reduction of I2 and I3, it has to be equal with the reduction of I1 and I2 and I3. This is called associativity. Maybe it will bring back not so good memories into your mind. I'm sorry about that, from elementary school. But associativity is really a key point in the reduction algorithm. Associativity works very well for the sum, but if I do the sum of the square, it will not work that well. And it's tricky because if the sum of the square is not associative, so it's not a reduction. I shouldn't use such a lambda expression as a reducer. The problem is, if I run my reduction step with such a lambda expression, it will work. The code will compile, because it's not the job of the compiler to test if my lambda expression, if my lambda reduction is associative or not. It will run, because it's not the job of the JVM to check that neither. And it will be reproducible. It means that if I take a given array with given values, and if I apply this reducer on this array 1, 2, 3 times, I will always get the same result. Now, if I apply this pattern in parallel, and we'll see how to do that later in this talk, it will not bring me reproducible results. That is, if I run that once, I will get maybe 12. And if I run the same application again, the same program again, I might get 16 or something. So it's a new category of bugs that is coming into the house, and that we will have to deal with those bugs. And it might be a bit tricky, a bit hard, because there's theory behind that. So what do we have so far? A lambda expression is basically a new way of writing instances of anonymous in a class. It's nice because it allows us to write less code. So since it is less code, it's probably more readable. It's not always the case, but it's probably more readable, and it's nice. But it's more than that. First, the syntax we just saw is not the only one I have available. I can write a mapper, for instance, person.get age. We already did that. I can also write it with this syntax, person, double colon, get age. It's just a reference to the method I want to apply on the person. And get age in that case is not a static method, so I can build a reference on this method even if it's non-static. Other example, for the sum, I've got a new method in the integer wrapper class, which is static, called sum, that will sum up to integer, so that I can use them in my lambda expression like that. And I have the same for max. I can take the max of 2 integer and write it like that. And it's also a new method. I've got the min, of course, also. And it's also a new method on the integer class. We'll get into more details with the max method and the min method, because those are also a bit trickier than it seems. I can do the same for lowercase of the class stream, but I can't pass a parameter. For instance, if I want to call 2 lowercase and gives a local as a parameter, I can't do it with this syntax. This is not possible. Okay, so more on the lambdas. First question I can ask is how can I model a lambda? What model a lambda may have, or can have? Second question, can I put a lambda in a variable? Well, I already did it, so I guess the answer is yes. And is a lambda an object? And this question is tricky, and I won't answer it fully. The answer will be given tomorrow in another talk. So first, a lambda is an instance of a functional interface. Functional interface is a new concept in Java 8. This is a functional interface, which is a partial version of an existing interface in Java.util.functions called consumer. Consumer basically accepts objects and gives you back anything in return. What does it have? First, it has only one abstract method. It can't have 2. Method from object don't count in this count. So if I specify equals, for instance, of toString, it will not count as an abstract method. And it can be annotated by a functional interface. This is optional, but I can do it. So a functional interface is basically an interface with only one method in it. This is the full code of the consumer method. We'll come back later on it. So here is an example of a consumer. I can build an instance of a consumer in the old way by building an instance of an anonymous in a class, just like that. This is Java 7 code. Or I can write it like that: consumer of string c equals c gives system.out.println of s. Those two ways of writing things are partly equivalent. They're not exactly equivalent, and we'll see an example in a minute. Question is, what is s? Once again, s is a variable introduced here. Well, it's not really variable, but it's introduced here, and I don't give a type for this. This I can't write that in Java 7. It's not possible. So what is the type of s? Answer: the compiler guesses, infers that s is a string, because it recognizes this as an implementation of the accept method, and since the accept method takes a string as a parameter, s should be a string. Basically, it's this that is happening. Side question: can one write this? Basically, I have a variable outside the scope of my implementation of anonymous class, and I want to use that variable inside this class. Well, in Java 7, it doesn't compile. It's not possible. Why? Because I should be final. I can only access values from outside the scope of my inner class. I can't access a variable. if I write this code in JDK 8, it does compile. I do not need to write the final keyword. And this is nice because in JDK 7, what do? I just call this Eclipse or NetBeans or IntelliJ or whatever shortcuts just to insert the final keyword for me. So here I can become lazy at last, and I don't have to write the final keyword anymore. But what happens if I decide to modify the I variable once it has been declared? Well, it does not compile anymore. And this can look a little tricky, but what happens, in fact, the Java 8 compiler states that this variable I is effectively final. That is, it is final, but I don't have to write the final keyword. So of course, if I want to modify it, it will not work. It brings me a compile error. So the semantics of the behavior of the inner class towards capturing outside variables, outside values in that case, has not changed, of course. What about this? If I get a reference, if I use the this keyword in an anonymous class, it will refer to the enclosing instance I'm in. So if I write this code and run it, it will print I'm in C, because the toString method is in the implementation of this anonymous class here. So this is this method that will be called by the toString call in a system.out.println. So in JDK 8 it doesn't change, of course. The semantics is still the same. But if I write this, which is supposedly an equivalent stuff of the previous writing, then this is not the instance of the lambda, it's the enclosing instance of where this lambda expression has been written. So you see that this equivalency between writing an anonymous instance and writing a lambda expression is not just a matter of building some kind of smart parser to rewrite things differently. It doesn't work exactly the same, on this example at least. So what model for lambda? Answer, we can model lambdas with functional interfaces. Can I put a lambda in a variable? Answer is yes. Is a lambda an object? Let's play the game of 7 errors, a simplified version, because it's early in the morning, with only one error. What is the main difference between this code and this one? So tell me there's no one error. There are as many errors as there are characters in the code, which is true. But okay, with one error. I think that the biggest difference, and once again this is completely new to Java, is the fact that in the first code I've got a new, and in the second code I don't have this new. When I write a new, I explicitly ask the JVM to create a new object. And creating an object might be a bit expensive because it incurs the reservation of some memory, initialization of the memory, calling static initializer, non-static initializer, calling the constructor. And there are many more things to do. When I write this code, I don't have a new. And once again, this is completely new. It's the first time in Java that I can instance something, create an instance of something without writing a new. I couldn't do that in Java 7. And the fact that there is no new here, I'm not asking the JVM explicitly to build me a new object. So the JVM will be free to optimize things on many dimensions because of that. So is a lambda an object? The answer is no, but it's a little no, because it might be an object in the end, but it's not an object in the sense we get it usually, at least in Java 7. What do I have in my JDK toolbox to implement lambdas? Well, I've got plenty of them in a new package called Java.util.functions. There are 43 of them, and it's a so-called starter kit. So you can, of course, write as many functional interfaces as you wish. I would like to categorize them. So the supplier is alone in its kind because there are several kinds of function. we have the supplier. We have the supplier doesn't take any argument and brings me and returns me an object. The consumer does the contrary. It accepts an object and doesn't return anything. A function takes an object and returns an object. A predicate takes an object and returns a Boolean. They are the primitive types version of those interface because it's all about performance. We'll see that in a minute. And since it's all about performance, I don't want to spend time boxing and unboxing integer longs and doubles. And I have the B version of those. A B function takes 2 parameters and returns a value. Here's an example, the supplier. This is the supplier. It's a very simple interface. The consumer just accepts an object, and I have I can chain consumer, so I can write C1 and then C2 if C1 and C2 are consumers. This is a pattern I'm a bit ahead of my talk, but I can write this kind of pattern, stream for each, and gives the consumer as an interface. B consumer takes 2 arguments instead of 1, and I've got the primitive types version of all these consumer. Object int takes an object as an argument and an integer primitive type as an argument. Same for obj long, obj double, and so forth. Okay, here is a function. A function it will be used for the mapping step of my MapReduce pattern. A function basically takes one object and returns another object of another type. Function can be chained and can be composed too, because a composition of function is another operation I can put on functions. B functions take 2 arguments. They can also be chained, and I have got primitive types version of those functions. A unary operator is a special type of function where the parameter and the return types are the same. The binary operator is a B function. B function takes 2 arguments. So the binary operator takes 2 arguments of the same type and return the same type as the argument. And the predicate is used in the filter step of the map filter reduce. It takes an object and brings back a Boolean. BiPredicate, okay, this part is a bit tedious. It's a bit of a catalog of what I have in Java.util.function. BiPredicate takes 2 objects and brings a Boolean. Okay, and this may be time for a few wave of questions. I would like to introduce and to welcome on stage Mr. Brian Goetz, that you probably all know, that will answer your question during this talk, and he's a guest speaker of us. Do we have questions? Yeah. On the? Yeah. Okay. Oh, we got a mic that needs to be set up.
So no, we're not on yet.
Okay, the mic that needs to be switched on.
We good? Okay, great.
Okay. Thank you.
So what we thought we would do is sprinkle these question and answer opportunities throughout the talk. So there's going to be 3 or 4 of them, I think.
Yeah.
And I've been watching the Twitter stream, and obviously while I'm talking, you can tweet some more questions. We had so I think we have 2 good questions so far on the material that you've covered. The first one was about the @functional interface annotation, and the question was, what's the point of that? Why would I want to do that? Since it's optional, it's not necessary. And the idea here is, you're right, it's optional, it's not necessary. The compiler will recognize that an interface is a functional interface simply by seeing that it has one abstract method, and it can use it as the target type for a lambda. So the annotation, what it does is it captures your design intent that this was intended to be used to represent a function, and just doesn't happen to be an interface that only has one method. And if you capture this intent, it flows through into the documentation, so that's useful to your readers. And also, you enlist the help of the compiler in enforcing this. So if you say @functional interface, and then you give it an interface that has two methods, the compiler will say, well, that's not a functional interface. So it's one of these things where you don't have to do it, but if you do it, the compiler helps you out, and the design intent is captured in the source code, and it's projected into the documentation. So it's a useful thing to do, but really mostly for writers of libraries like the JDK than typical application developers.
Okay.
So that was one question. The next question, which is actually a very deep question, which is, does it have to be an interface that is the target type of a Lambda, or can it be an abstract class? And, well, it's a very simple question. The answer is no, it can't be an abstract class. But the why question, which I think is the follow-up, yes. is actually a very deep question. And so there's a lot of accidental reasons why converting Lambdas to abstract classes would be complicated, like what constructor do you invoke? Do you require that it have a no-arg constructor? But really, the real reason is, if we supported conversion of Lambdas to abstract classes, it would really make the whole model for Lambdas much more heavyweight. It would basically turn Lambdas into basically just syntactic sugar for inner classes, as opposed to what we've done, where Lambdas are actually a representation of a function, which is a much lighter weight thing than an object. And we've been able to make a lot of really nice optimizations in the implementation that give us better performance and give us a lot more simplicity. So Jose mentioned about the meaning of this inside a Lambda. It's a little bit annoying that the rule is different inside Lambdas than inside inner classes, but the rules are actually so much simpler with Lambdas. And Lambdas, it's really simple. A name inside a Lambda means exactly what it means outside of a Lambda. Whereas in inner classes, the name lookup rules are very complicated. So we deliberately made a choice to simplify the model. And as a result, we got a lot of benefits, but it means that if you have something that kind of looks like a Lambda, but it's an abstract class, okay, you don't get to play along. So that was a compromise, but it was, it turned out, I think, to be a very good choice. Couple more questions. I'm not sure I understand this question. How are Lambdas with more than one argument implemented? It's pretty straightforward. The type of a Lambda is modeled as an interface that has one method. So if that one method has more than one argument, then you have a Lambda like x comma y arrow, x plus y. That will turn into a method that has two arguments, int x comma int y, and the body just has two parameters. So Lambdas just boil down to methods. You can think of Lambdas as anonymous methods or literals for methods. There's nothing magic about one argument, two arguments, etc. Yeah. And more questions coming in. Cool. One of these I'll take for later, which is about the challenges of making the collection functions work in parallel. We'll take that later because we're going to talk a lot more about that. And then, this is an interesting question. Why did Java 8 introduce effectively final variables? It seems confusing, and adding final isn't that annoying. So this is you can't win. Right? The number one complaint, well, not the number one complaint, but like people complain endlessly about why do I have to type final when the compiler just knows it. So most people seem to think having the compiler infer this for you and not making you type it by hand is a wonderful, wonderful thing. Some people apparently think that it's, oh my God, another rule to learn. But it's really quite simple. The rules haven't changed. Lambdas and inner classes capture values. They don't capture variables. Historically, we forced you to type final as a way of saying, this is a value, it's not a variable. Now the compiler is a little bit more relaxed. It can observe how you use the variable and says, oh, you only assigned to it once. It's effectively final. I'm going to infer finality. I'm not going to make you type it out. So it's not really a new concept, but, okay, some people are a little bit made nervous by this. Okay, so I don't know how much time do we want to take on this one? Should we take?
Yes, I think it's okay.
Okay, we have a few more minutes. Okay.
Yeah. Okay.
All right. So the question is, what about performance? Great question. Okay. Will they be faster than anonymous inner classes? Yes, they already are. So I've got a talk tomorrow afternoon called Lambdas Under the Hood, where I'll be talking about how this is actually implemented in the VM. And this isn't syntactic sugar for inner classes. Lambdas are already faster than inner classes in a lot of metrics. And in the remaining metrics, they're exactly as fast. So basically, there's no case where Lambda is slower than an inner class, and a number of cases when it's faster. In particular, linkage costs are faster, which is to say the first time you use an inner class, it would have to go out to disk, read the bytes off disk, load the class. The corresponding operation for lambdas is a lot faster, and capture is a lot faster because, as Jose said, with a lot of lambdas, you're not creating a new object. It's able to reuse the same object, and that makes capture a lot faster as well. So lambdas are already faster than inner classes. All right, so someone says, why does the lambda keep a reference to the outer class when passing a final reference? It only keeps, so inner classes always keep a reference to their enclosing class. That's just part of their definition. Lambdas don't do that unless they have to. If you explicitly use this, or capture a field, or capture a method of the enclosing class, then it will hold on to it. But if your lambda is just, x, y, arrow, x plus y, it doesn't capture anything. It only captures the absolute minimum it needs. And that's another reason why lambdas are faster than inner classes, because they don't carry around as much baggage. Okay, let's see. So all the ones shown so far have been in a single line. Can you use a code block? Yes, you actually gave an example of that. If it's a single expression, you don't need any braces. It's just the body evaluates that expression. If you have multiple lines, you enclose it in braces, and then you can have return statements and the same. And the questions are coming in faster than I can answer them. So at some point, I'm going to have to stop here. Some questions about the implementation. Are they converted to singletons or static classes or instance per implementation? Come to my talk tomorrow. I will explain the implementations in great detail. Serialization. Oh. Okay.
You'll answer that tomorrow too.
Yeah. So the short answer, so the question is, what about serializability of lambdas? Is there a short answer? Well, the short answer is, you can make them serializable if you want to. They're not serializable by default. But if your functional interface extends serializable, the compiler will see, oh, okay, I have to implement predicate and serializable. I can do that. It's a slightly more heavyweight thing, but it does work. It was really nasty to make it work, but we made it work. But we hope you won't use it a lot, because serialization is unpleasant. How do they appear in stack traces? That's a good one. So what you'll see is if you have a lambda expression in your code, like the age greater than 20, what will happen is the compiler will take the body of that, create an actual method in your class. It'll have a horrible name like lambda $23, and that will actually show up as a stack frame in the call chain. So you may see some extra stack frames, that correspond to methods not created by your code, but that have been added by the compiler. You see the same thing happens with bridge methods. Yes, we're being photographed here. It's hard to talk when you're being photographed.
Yes, very hard.
It's very distracting, but I'll try.
Thank you.
Thank you. Let's see, a couple more questions here. Are map and filter lazy? Yes, but you'll talk about that a lot more. We'll bring that question back when it comes in. All right, I think that covers most of the questions so far. So why don't we keep going, and we'll come to the next section.
Okay,
well,
fine.
Okay. Thanks, everyone.
Thank you very much. We'll see you later in a minute, because we have 3 other time slot for questions during the talk. Okay, so let's go back to the map filter reduce pattern. So far, we have this new concept, this new lambda concept, and of course, we need to apply it to the map filter reduce pattern, because it's at the core of so many applications. So how to apply this to a list of person? In the JDK 7, the legal way to do it is to iterate over the elements and apply the pattern. We saw that previously. In the JDK 8, what I want to do is to separate the iteration part. I want to put that into the API, because I want the API to be able to optimize this part specifically, especially for parallel operation. And I want to just call this with a minimum of argument. And the two arguments I need to pass to this is the list of person, of course, and the different lambda expression that will model the map, the reduce and the filter and the reduce steps. So how could I do that? Well, I could think of creating a helper method. There's no lists in the class in the JDK, so I could do it like this. This is still JDK 7. I just give the person list as a parameter on my mapper, implemented with an anonymous in a class. If I write it with lambda expression, it will brings me this, which is much lighter and I guess more readable too. Or it will give me this with this new expression that just gives the name of the method to be called. Okay, good. I need to be a bit wary because if I want to be able to pass a manager list as a parameters, and I want that to compile, so I'll need to use the wildcarded generics, which is always a bit painful, I think. Well, but it's doable still. And this could be the implementation of the mapper method. It's a very naive implementation, well, it's the implementation I could write without thinking of it, of course. And if I do that for the filter and for the radius, I didn't write all the details, but I will end up with some kind of pattern like that. So call the map on this lists helper class, then call the filter and call the reduce. And of course, all those three methods will return a list of integer as the ages. This is the mapped list, remember. The mapping changes the type of the list. And this is the return list for the ages. This is the filter list, less element than the ages, and I will end up with the sum. This is a nice way of writing things, and this is exactly what I want to do because I just push the information to the API, let the API do the computation, so I can optimize stuff without changing my code with it, which is exactly what I want to do. So this is great. Okay, so this is the pro. Let's examine the cons, if there are any. There might be some cons for this pattern. Suppose the person is a really big list, several millions, tens of millions, hundreds of millions of persons in it. What do I do? First, I duplicate this list in ages. If person is not a big object, ages is an integer, it's not a big object, but still, I'll duplicate this. This duplication comes with a price, of course. Then I duplicate it a second time. Ages greater than 20 will be smaller than ages, but it can be like 50% of the size of ages. So I pay this duplication once more. If I've got another mapping step, I will pay a further duplication. And what do I do with those collections? Well, I send them to the garbage collector because I don't have to do, I have nothing to do with them. So I just pay the high price to create them, just to send them to the garbage collector. This is something I don't want to do. I know there are probably very clever people working on the garbage collector who would be keen to know that their stuff is used heavily, but still, it's not a very optimized way of doing things. So this I don't want to do. This is a con. Now suppose the algorithm to compute the map filter result, the algorithm that is in the API, is already optimal. But my boss comes to me and tells me, okay, the application is not fast enough, it has to go even faster. The last step of optimization I can use is going parallel. This is the only solution. What do I need to do to go parallel? Well, I can write parallel code inside the lists class with some kind of fork join or whatever. But then I need to have concurrent array collections here. I'm not free to choose any kind of implementation I need. Because if it's not concurrent array, I will have trouble even if I have only thread that execute this code. Inside the parallelization, I will create more than one thread, and each thread will take care of some piece of the person's list here. So those lists need to be concurrent aware. Okay, so this is a second con. Now suppose I have an all match reducer instead of a sum. The all match is a special kind of reducer because it doesn't need to know all the list here of names to know if if the result, the return value has to be false. Here is a very simple, very basic implementation of all match. What do? As soon as I find an element for which the filtering is false, I return false. I don't need to iterate over the whole list. But then I missed, once again, a huge room for optimization because the names list here has already been evaluated. I already paid the price of the duplication on of the mapping when I begin to execute the all match method here. I really lost a huge opportunity for optimization because suppose I've got 10 million person in my list and that the second one will make the all match filtering fail, then I could have the result much, much faster than what I had here. A good approach for that would be to apply the filter lazily. But of course, with that kind of thing, it's not what I'm doing here. So this pattern might look nice, but I've got only one pro, which is it's nice. Okay, it's still nice to be nice. But I have 3 cons that are really very important in my application because they are just performance hits on my application. So this pattern is just not the right one. I need to realize that I can't write things like that because it will lead to poor performance, and this I don't want. And the same goes for this one. Putting a map, filter, reduce method directly on collection or on list will lead to poor performance and little room for optimization. So what's the deal in having lambdas, having wonderful new things, fast, with good performance, and crappy implementation to use them? It would be just useless. So I don't want to do that. I don't want to do that, and I might have to question, but what about in-place operation? Okay, I don't like duplication, fine. What do I do? Why can't I do my map filter reduce in place? Just because it's not possible. As I told you, the mapping is changing the type of the collection. So since I changed the type of the collection, I can't map a collection in place. Doesn't make sense. I could do the filtering in place, but the filtering might not be the most expensive step, so it wouldn't bring me big optimization, but still with concurrency issues. Because if I want to go parallel, then once again I need a concurrent or a collection for the filter. And of course, an in-place reduction doesn't make sense. So in-place operations is not a viable pattern. It just doesn't work. It's not the right things to do. So once again, we need a new concept, specially tailored to handle especially big lists efficiently. That will allow all the optimization I want to do, laziness, and avoid duplication of huge lists. And unfortunately, the collection framework is not the right place to implement all these methods. Still, my data is most probably in a list or in a collection or in a map. So I'll need to connect the collection framework to this new concept. But I definitely need something else. Okay. So back to the beginning, what pattern to choose? If I had put those methods on the collection interface, it would have led to such a pattern. And even if it doesn't work, it's still a pleasant way of writing things and a pleasant way of reading things, which is probably as important as writing, because we all know that we spend 19% of our time, our developing time, to read code, reading code instead of writing code. So code has to be readable all the time. It's still a pleasant way of writing things. So what about writing this? Since I can't put it in collection, I need to put it somewhere else on another concept, which will be the stream concept. So what about writing, adding a method called here? It seems to solve all my concerns, because the map, filter, and reduce method are not called on the collections anymore, And so I'm completely free to create anything I want, to avoid duplication, for instance. I'm completely free to implement laziness, and I'm completely free to implement parallel operations too, since it's all new, it doesn't exist. So let's do that. If I do that, I needed to put a new interface and collection. Let me go back to the previous slide. This stream method, this stream called, is called on a collection. Persons is a list of persons. So I need a new method in the collection interface. Collection interface has been around for 15 years, 1998, Java 2, and it's quite widely used, I believe. If I do that, of course, ArrayList doesn't compile anymore. And all the implementations that have been written of the collection interface fail to compile after that. So I've got two solutions. Either I tell people, okay, no problem, you refactor your code and you recompile it. I guess the carbon signature of such a refactoring would be probably too big for the global warming. So something has to be done that will avoid to change the existing implementation or to recompile all the existing implementation of collection. This is something that is really amazing with Java, is that for 15 years, Java has been around for more than that, by the way. You take some code compiled with an old version of the compiler, and most of the time you can still run it on the JVM without recompiling it. So I need to find something for ArrayList to still compile after that. No, this is the second time slot for questions. Sorry. Maybe it's a bit early? Do you think it's early? Yeah? No? Okay, let's carry on. This is...
we're skipping it, okay. All right.
Sorry?
Are we doing questions now? Or?
Yeah.
Okay.
I think we can have questions now about the stream API and stuff.
All right. Perfect. All right. So I got a few more questions in the interim. A few more people asked about this final thing. So, but it's a fair question, right? So the question is effectively final not confusing? Isn't it more clear to just write the final keyword? And we're not taking away the final keyword. So whenever you have a feature like type inference that lets you either express something explicitly or omit it, you have a choice about whether I want to write it explicitly or omit it. And the same thing is true with typing of Lambda parameters, right? You can write your you can write your Lambda as p arrow, p dot get age, or you could write person p, arrow p dot get age. And it's up to you. So how would you choose? Well, you choose on the basis of which makes your code more clear. Sometimes being explicit makes your code more clear. Sometimes being implicit makes your code more clear because it removes some of the extraneous noise. So as a programmer, you get to use judgment to decide which of these different ways of writing the same thing yields a more clear solution. And so think of it not as a new feature, but as an option for you can write it in a more compact way, or you can continue to write it in the old way. Okay, so let's see. Here's a question which I think is a nice question. How do I share lambdas in my project, or should I even share them in my project? And a good way to think about this is lambdas sort of look differently depending on which side you look at them from. So from the perspective of I'm creating this anonymous function, you use the lambda syntax to represent your arguments and your result and all of that. But once the lambda is evaluated, once the lambda is instantiated, nobody else can see it as anything but an implement as a instance of the interface. So from the outside, if I hand you a function or a predicate or a runnable, you don't know whether it came from a lambda or from an anonymous inner class or from a named class, and you shouldn't have to know. So lambdas are a convenience for writing, for writing little snippets of behavior in a more clear and compact way. But once you publish them by sticking them in, say, a public static variable, it just looks like an instance of an interface. So from the other side, people don't know that it came from a lambda. You can refactor from an inner class to a lambda and back, totally an implementation detail in that sense. Okay, so a few more questions. How does lambdas in Java compare to lambdas in .NET? So this is kind of an interesting question. The basic concepts are exactly the same. It's an anonymous method. You have methods in .NET, you have methods in Java. The real difference is in how the type system represents it. So in .NET, you had delegate types from day one. So that was a form of function type. And so the type of a Lambda expression in .NET is a delegate type. The type of a Lambda expression in Java is a functional interface type. So it's how it gets reflected in the type system is the big difference. The syntax is pretty much exactly the same. They use the fat arrow, we use the thin arrow, but that's basically the extent of the difference. The concepts are the same. Just how it fits into the type system is a little bit different. Okay, when will JDK8 be GA? End of first quarter next year, March of next year is the GA date. So it's a little sad that it takes so long. I mean, from an engineering perspective, we're pretty much done. We're in the ramp down phase, but the testing and stabilization back end on a product as big as the JDK does take a while. Okay, so here's a question. With Java 8, what is the concrete type of the collection returned when you call collection.map? So there is no collection.map method.
No.
And as Jose mentioned, you could sort of think about what these methods would look like, having collection.filter return a new collection, having collection.map return a new collection. But when you kind of work through the details, it turns out that's not what you want. And so we introduced this new abstraction called stream, and it represents the set of values that you're operating on that are kind of disjoint from how the values are represented. So data structures like ArrayList and HashMap are really concerned with the memory layout of where the data is and the storage and retrieval and insertion and deletion. And so that's the job of a data structure. Stream is more about I've got a stream of values and I'm going to apply a set of computational operations to them, filter them, map them, sort them, add them up, etc. And so it's concerned with something different, and so we created a new abstraction for that. So when we get to the API for the stream interface, you will see that the map method on stream returns a stream. The filter method on stream returns a stream, and that's how we implement laziness, that we don't actually do the work. When you say stream.map, we just remember when I start pulling elements from the stream, I have to apply this mapping function. Okay, so a couple of nitpicks on your code examples.
Mm-hmm.
Not really worth it. Okay, so further question on capture of variables and values in lambdas. So if someone says, if I say int I equals 0 and then I equals some new value, can I later use I in the lambda? No. So lambdas close over values, not variables. So any local variable that you reference from within a lambda has to be a value. It has to be assigned exactly once. So if it's assigned more than once, the compiler is going to assume that it's mutable. You may assign it, again, and it won't let you do that. If you reference a field or a method of the enclosing instance, it treats that as a capture of the final variable this. So lambdas close over values, and if you reference the object, it treats it as closing over the identity of the enclosing object. All right, so one more question just came in. What is the benefit of a stream compared to returning a lazy list when doing list.map? Okay, so this is an API design question. Why didn't you say introduce a concept of lazy list? It would be very confusing because you have there are certain methods that would force you to collapse the laziness, right? If I say I have a list and I want the size, well, maybe it's a lazy list. I have to do a whole bunch of computation to compute the size at this point. And we experimented with putting all of these methods, filter, map, etc., on list, and it was possible to do, but what we found, it was very confusing to people because you say list dot and then control space in your IDE, and it shows you a bunch of methods, some of which were eager and some of which were lazy. Like filter would return a lazy collection, but retain all or remove all would remove them in place. And we looked at that from the perspective of if some new developer shows up and sees these different methods, and some of them create a new collection and some of them mutate the existing collection, it was just too confusing. It turned out to be a lot cleaner and simpler to say the methods on list mutate the list, they operate in place on the list. The methods on stream allow you to compose these computational operations on streams, and it was a much cleaner separation. So, the question you have here, which is, why didn't you just do it this way? That was sort of the obvious first way to do it. We spent a lot of effort going down that way. It turns out that the obvious first idea is usually wrong. And I have a few examples of that in my talk tomorrow where I point out some, here was the obvious solution and it was just wrong. And here was the other obvious solution, it was just wrong. It turns out that the first thing you think of is usually wrong. Which is why it takes so long to release a new JDK version. Because you have to work through all those wrong answers, because we wouldn't want to burn those wrong answers into the JDK for all time going forward.
Especially this one.
No, we wanted to get this right. Okay, one more question here, and actually two more questions, and then I'll stop. The double colon method reference syntax, basically you can think of method references as shorthands for certain kinds of lambdas. Some lambdas, all they do is take their arguments and turn around and pass them to some existing method. And if you're going to do that, you might as well reference the method by name rather than describing how you would call the method. So it's just a simplification in that sense. They get treated just like lambdas the way they get converted to instances of functional interface. It's just a shorthand for a particular well-behaved kind of lambda. And then last question for this section. Are there more reasons not to extend iterable than breaking existing code? So we actually looked at, in the first the round of the Stream API, basing it off of iterable. And what we found was iterable was too constraining. We wanted to be able to retain additional information about the source of the stream, which might be not just a collection, but could be an array or a generating function or what have you. And at the same time, there were so many classes that implemented iterable that we didn't want to add a lot of new methods to iterable for fear of both semantic questions and also for for fear of having name clashes. And so it just made a lot more sense to create a new abstraction that was suited to the task rather than repurposing an existing abstraction, which, by the way, is fundamentally sequential, right? Iterable gives you an iterator, and iterator is fundamentally sequential, and you have has next and next methods. Wasn't really the right choice for doing parallel stuff. So, okay. Back to you, Jose.
Thank you. So we need new interfaces to implement that because we need to change the collection interface. How to add method to an interface without changing any of the implementation. This is the challenge, in fact. And the solution must be to change the way interfaces work in Java. So this is the new collection interface. Just add one method. In fact, there are more than one, but which is the stream method. And ArrayList needs to know the implementation of stream, but I can't change the implementation of ArrayList. So what do? Well, I just put the implementation in the interface. And this is a new concept, one more new concept in Java 8, the concept of default method. What is a default method? It's a method that lives in an interface. It has an implementation and the default keyword in front of it. So this is a default method. It's not, this method doesn't impose itself over the classes. We'll see that in a minute. But it is available for, namely ArrayList, to get this implementation and to still compile. Okay, new concept. Default methods are here to enable the evolution of old interface. And when we're talking about old interface, we're talking about, of course, the collection framework, which has been designed 15 years ago, and probably more than that. Does it bring multiple inheritance to Java? Well, in fact, we already have multiple inheritance in Java. Look at the string class. It inherits the type of serializable, comparable, and call sequence, which is another interface. Okay, so we already have it. What we have so far in Java is the multiple inheritance of type. what Java 8 brings is the multiple inheritance of behavior, which is different. Think about the implementation. And what we don't have is the multiple inheritance of state. We don't have it, and we don't want it because it's where the trouble is. Will we have conflicts of multiple inheritance? No, we won't have any conflict. No conflict at all. But in case we have conflict, maybe we need some rules to handle them. Okay, so let's see that in an example. I've got a class C that implements A and B. A and B are two interfaces. In those two interfaces, I've got a default method which is the same signature, default string A. Okay, so what happens in that case? What implementation will be chosen by the compiler? First, if I override the implementation in the class, then the rule 0 is class wins. If I have the implementation in the class, no default implementation will be used at all. So this is nice, and this is pretty simple to understand. Now, if I have still this class C that implements A and B, and if I write it like that, I will have a compile time error. And this is very nice because this error will show up in my IDE. So I can fix that error before sending my code to production. It will not crash my application to have this kind of error. And this is exactly what I want. So in that case, what happened? Well, class C basically can't choose between the default implementation from class A and default implementation from class B. So I need to fix that. I can fix it by telling that interface A extends interface B. Then in this case, A is more specific than B. So the most specific implementation, default implementation is chosen. Now let's take another example. I've got a class D that extends C. C implements A and D implements B, but A extends B. So the first things I see when I see that it's really badly written. Maybe developers could think before writing such code, such ill-designed code, because class C, which is more abstract than class D, implements a more specific interface than class D, which of course doesn't make sense. But anyway, so how does it work? Do I have a conflict here? Well, in fact, I do not, because class D implements both A and B. A is more specific than B, so the previous rule applies. And the implementation is A, it's chosen in that case. In case I want to specifically choose an implementation of my default class, I have this syntax that will allow me to reference specifically the default implementation from interface B in that case. Okay, so I've got three very simple rules. The first rule is I need to handle the multiple inheritance of behavior, which is new to Java 8. First rule is class wins. Okay, very simple. Second rule, more specific interfaces win over less specific. Second rules. In fact, I already have this kind of rule for other questions in the current JDK. And in fact, there's no rule 3. There are only two rules to handle multiple conflicts. So this is an example. So this brings many good things in the JDK, even in the existing interfaces. Think about the iterator interface. You've got three methods: next, as next, which are usually the method we want to implement. And I have got the third method, remove. Most of the time, I don't want to implement this method because I don't need it. But since it's defined in the interface, I need to implement it with some kind of basic implementation, which is always the same. So I just copy-paste my code and make my Jenkins guy and Sonar guy shout at me because of that. But anyway, so this is the JDK 7 way of writing an implementation of iterator. But now iterator has evolved. The remove method is not an abstract method anymore. It's a default method that throws the exception for me. So I don't have to write useless implementation of this method anymore. It has already been implemented inside the iterator interface. Isn't it nice? I love that. So the concept of interface changed in Java. And this is not the only change. You probably all remember the time when your first Java classroom and you had a teacher that had you write this example. Well, now teachers will have trouble because they also write that. You can add static method in interfaces and run them. So you can do two things now in basic classroom. Okay, so the new interfaces in Java 8, we have default methods. It brings multiple behavior inheritance, rules to handle conflict, very simple rule, very basic, very straightforward. And we have static methods in interface that are allowed. And those static methods are also used in the Lambda expression, for instance, to chain some lambdas or to compose functions, as I showed you a few minutes ago. This basically will bring new patterns and new way to write APIs, so this is really great. It's an opportunity for improvement and innovation. So what we have a new syntax, Lambda expression. We have a new pattern to implement, the stream API. And we have new interfaces to keep the backward complexity. So we are in a very good situation, I think. Where are we going to? What do we need to talk about still? We need to talk about the stream API to describe things and how we can use them. We need to talk about reductions more thoroughly because we didn't really do so far. And we need to talk about performances and especially parallel performances. And we need to talk about a wonderful class called collectors that will be the end of this talk. But for now, I think it is a good time for a little coffee break. What about that? Huh? Everybody's okay? Thank you. We can see you in, let's say, 20 minutes? 5 past 11? Okay, that's fine. Okay, thank you very much.